Hello, my friends, and welcome to Lesson 6 of Unit 3, which is on prescriptive analytics. So, in this prescriptive analytics, we are going to discuss 5 topics in detail. So, I'll be introducing you to the prescriptive analytics. Then, we'll talk about the two models that we use, optimization and simulation model. We'll talk about artificial intelligence in business and how we use voice and natural language processing in business, and will also touch upon artificial intelligence and strategy. So let me go back to this diagram which we used to call as analytics value escalator. So we have talked about descriptive analytics, diagnostic analytics, predictive analytics, and today we are going to talk about the prescriptive analytics. And not the next level, we can use that is the artificial intelligence. Now remember this thing that if we are talking of prescriptive analytics, it is not in isolation. So you are using the results from descriptive, diagnostic and predictive analytics for the prescriptive analytics. So it is not in isolation, it is in continuity, but the value addition gets enhanced as we go from descriptive to prescriptive analytics, which we have been discussing. So we will be talking about two major things today. One is I'll be talking about optimization and simulation. And second, I'll be talking about the artificial intelligence in business, where we use NLP and text recognition. And also, I'll talk about how to use AI in strategy choices. So if I continue with the same example of policing and looking at the crime rates, which has been increasing in the parts where we saw there is power surges, that means there are power cuts because of certain reasons. And we were able to come out with our hypothesis, and we knew that there was an average increase in the crime rate through our predictive analytics. So now question is what to do next. So the police decided that all these areas should be properly lit, all the street lighting with 24/7 power supply should be restored so that the crimes are reduced in those places. So that is, and we are using minimum resources because we know exactly which are these places, and then we again start observing whether what we had predicted and what we have prescribed is working for the benefit of the citizens in that cities or areas. So that completes our example from the concept to the last value addition, that is in the prescriptive analytics. Now the application of prescriptive analytics can be in any domain. So some of the examples which we can think of is, like for example, how many of our different products, because you have a product mix, should we produce or stock? If it is a retail store, so which all products we should stock. So these are some of the prescriptive analytics based on the predictive analytics that we have projected. What should our supply chain network look like for the next 5 years? What price should we choose? So we have all the details with us, and now what we should prescribe, which price we should be using. Should we launch this new project after we have done all the analytics and we have predicted the various outcomes? So should we launch this new project or not? So all these prescriptive analytics usage in different applications can be there. Now if I want to talk about the two models that we use in prescriptive analytics to take up a simple example, although it is not very simple in real life where we use very complex examples, but for the purpose of understanding, let us take the optimization model. And you have already done, so I just need to summarize the things, and then only the concept we can discuss, because in one session I cannot take up hands-on and all those things. So let us talk about a company which is making bicycles, and they make just two different models. One we call as a fancy model, and the other they call as a standard model. Very simple. And I'm not talking of the sizes or the colors or other things. Keep it very simple. Two models. One is fancy and one is standard model. So now, through the optimization model, prescriptive analytics, we would like to answer two things. One, how many of each model to produce and what price to sell them at. So these are the two questions we need to answer. So that is the prescription we would like to give. How many of each model to produce and what price to sell them at. And we have done all our studies, we have done our predictive analytics already. Okay. So now here we, in the optimization model, we will talk about three elements which you require for your optimization model. So number one element of optimization model is decision variables. So there are four variables, and I denote the fancy bicycle with F and the standard bicycle with S. So PF, which is written below the standard bicycle, PF is the price of the fancy bicycle. Quantity is QF. Q is the quantity and F is for the fancy model. PS is the price for the standard model and QS is the quantity for standard model. So these are the four decision variables, and we want to know the value of these. The objective function, what goal do we want to achieve? So I want to maximize the profit, that is my goal. And how can I maximize? I can say I will write maximize the price of standard into the quantity of standard. I need to identify these two, plus the price of fancy into the quantity of fancy. So that becomes my objective function. Second element. Third element is the constraints. So what real world constraints do we have? Let us say I want to maximize this. So my constraints would be subject to the quantity for standard model is less than equal to the demand at the price which I am keeping. So there has to be a demand for that quantity which I am going to produce. So I have done my analytics before, so I know what is the demand figure, so I know that constraint. Second is similarly for the quantity of the fancy bikes, it should be less than or equal to the demand at the price which I want to keep. Like you remember willingness to pay and all that, so we have done all that. And the third constraint is the quantity for standard plus the quantity for fancy should not be more than the production capacity that I have. How many bicycles I can produce, what is my capacity, so that is another constraint. And of course the quantity for standard, quantity for fancy, and the price for standard and the price for fancy should not be negative or zero. So these are the four constraints. So I need to put that, and then I put that in the software, and I get optimized model where I get the quantity of standard and fancy and the price of standard and fancy. So that is optimization model. If I talk of simulation model, right, the best example I can give you of a flight simulator. So what you do that since you cannot have an optimization model because it can't be put in so many constraints and so many optimization equations, so the elements will be very complex and you won't be able to know the relationship also. So what I do, I try to simulate, I try to come up with a computer model. Now how perfect, how good the model is, that is over a period of time, and that is where the machine learning comes, that is where the artificial intelligence comes. So what we do, we try to replicate the actual model onto a computer model, and then we try to make the model, computer model, learn the actual model. And once we feel that they have learned, then we try to play with that model. So I'll take one example so that you can understand. Now, for example, I'm running a retail store, and there are 3 people working in my retail store, as you can see through this. So there are 3 people working in the retail store: yellow, pink, and blue salespeople. And we have the customers coming. There is a point of sales terminal there. So firstly, I'll replicate this model, and then I would like to know from the simulation model that if I keep the 4th worker, will my profits go up? Will my operations be more efficient? Or will it not work? And the cost of the 4th worker will not justify the rise in the sales. So I need to do that. So what I do with the 3 people working in my retail store, I build a simulation model. I simulate that onto the computer model, and then I try to work out what all things they do, how they connect, relate to each other, how they take care of the customer, and how many customers come at what point of time, and so what is the cohesiveness, and how they are able to handle the sales, and what are the peak times, what are non-peak times. So all that model is built. And then what I do, once I am comfortable with that model, simulated model, I put the 4th person in this. And with that, then I can now prescribe, okay, does it make sense to have the 4th worker there, or it will be too crowded and I don't have enough traffic or enough people who come to my store that I need the 4th worker. So a simple thing. So this is all about the prescriptive analytics, the concepts which I gave you, and you can use the machine learning and AI in that. Now question is the use of artificial intelligence in business. So if I talk about decision making today, so a lot of AI is being used in the business. So if I go to Google Trends, as you know, you can check anything, what are the trends. And if I try to search for machine learning, artificial intelligence, and data analytics, the chart which I'm showing you, and this is for the past 5 years, like from 2012 to 2017, what are the Google trends, right? Now this is for the category of business and industry. So that means it is only for the business. I'm looking at the machine learning, artificial intelligence, and the data analytics. If you look at data analytics, so from 12 to 2017, it has really gone. So it is almost touching 100. So almost every company is using it. So on the other side, when I look at the artificial intelligence, which is the red one, so it is coming up, and from 2015 onwards, it has really been used in the business houses. And if I talk of the machine learning, that is more popular with the business houses. So if I look at the machine learning and the artificial intelligence, they are really picking up very fast. Now, so far what we have been doing is that you have a manager who is looking after, for example, if I talk of the retail store only, so when the things are to be ordered, when the customers are more, how to increase the manpower, the salespeople. So all these things, the decision making is done. So this is done on the manager's judgment. But slowly now managers are now using the machine learning, and they're using, of course, the data analytics as the first step. So, but if a question is asked to the manager that why the sales is down, he may not be able to, or she may not be able to answer that without, of course, the data analytics. But if I have artificial intelligence there, right, I can immediately look at why it is down and what prescriptive measures I can take to remove those constraints from there. So slowly So artificial intelligence is taking over the businesses for most of the decisions which generally are taken by the managers. So slowly it is replacing and not being a tool in the hands of the manager. So that is the scenario which is happening in the business houses. So if I talk from 2017 to the current times, so this is again increasing very fast. So it is going up tremendously, but the trend is the same, as you can see. So let me talk about voice and NLP. So natural language processing, what we call, and all of you might be knowing about Alexa, Cortana if you are in the Apple environment, and if you are in the Google environment. So you have all these NLP mediators wherein you don't have to use your hands or anything, so your voice will be the input, and based on that they are going to process whatsoever you want. So let me talk about an example of a bank and customer service. Now what is happening is most of the banks are trying to work on voice and NLP, and especially the customer care. If we talk about the customer care to begin with, or the customer service. So I pick the phone, I want to talk and I want some service. So it is being replaced with voice and NLP through artificial intelligence. So why it is happening? You know, a person who is working and may be available 24 by 7 as you have these call centers, but may not be knowing the history of that customer. And for that, you use the data analytics, but it will take some time, few seconds, if not few minutes. Whereas the moment you have recognized the voice, the complete data, the complete background of the customer is known to the Alexa, for example, and they know exactly what you're looking for, what are your preferences at this point of time, what is your requirement. So they know the entire history and they can respond within microseconds. And it is very cheaper for once you have tested the model, so it becomes very cheaper. And people after a certain time they leave also, they take all that intelligence with them, and they may not be able to, all are not competent enough to offer the right product at the right time to the right customer. So slowly the banks are looking at giving voice and NLP a big try in the customer service. And at all times you are connected with your data analytics up to the prescriptive analytics level. And slowly the AI, the next form is the cognitive technology. Cognitive technology is nothing but the AI, use of AI for specific things which the people are doing, like the customer service executive is doing. So you give a cognitive technology for that, and that is being used using voice and NLP. So that is what about how the banks are working. Similarly, different domains are working with voice and NLP, because that gives you a feeling also as if you are talking to someone, and that is very natural, which comes naturally to you rather than using computer going there. Now, the last one I would like to talk about, which is very, very important, is AI and strategy. So how you can use the artificial intelligence in picking up the strategy. What are the strategy choices? Which strategy you would like to pick? Now let me take one example so that I can illustrate in a better way. So if I'm a bank and I have two cards, let us say two credit cards. So and they have different features, like there is card A which is high interest rate and which offers good rewards and there is no fee on that, and there is card B which is having a low interest rate, there are no rewards and there is an annual fee. So these are the two cards, depending on different categories you want to test these, and you want to know which one is more popular with the people. So what you do, you run your predictive analytics as we have done in the A/B test. So you do your A/B test, and then you will come to know which one A is better or B is better in terms of the clicks or new accounts that the people are asking for. So, but for how long you will be doing this A/B test? So that is the thing. So because this world is very dynamic, people preferences keep on changing and the times keep on changing. So now let us take a real example where as a bank I have 100 cards and I want to advertise for these cards. So shall I keep advertising for 100 cards so that people can have all the 100 cards? So that is my question. So here comes another concept which we call as exploration and exploitation. And this is just in the case of a company with 100 cards. It can be any strategy that you have to pick. So what should be your strategy? Shall I keep on advertising for 100 cards? So let me talk about first exploration. In exploration, what I may decide, I keep advertising for all the 100 cards for many days, let us say for 30 days, to learn more about what customers prefer. I'll come to know, okay, now these are selling more or this is selling more. So what are the plus points? We can better learn which card customers prefer after 30 days, of course. And what is the negative? We waste a lot of time and money on cards customers don't like. So if, for example, there are 30 cards which the customers don't like, I'm wasting my time, right, for 30 days to figure out that these are the 30 cards which the customers don't like. Well, I'm advertising for 30 days and I'm exploring for 30 days. The other is exploitation. In exploitation, what I do after a fixed time, let us say one day, we see which card customers like most and only advertise that card. So out of 100, we have come out, this is the card which everyone likes, so we'll just advertise on that card. What is the positive? If that first day card is really the most preferred, we get the maximum performance because then we are putting all the money of advertising of 99 cards into that one card and we get the returns on that. But negative is if we are wrong because of any reasons in that one day, there could be some other cards which the people prefer and they didn't listen to my advertisement or because of any reasons in one day I can't judge and I've missed and I'm looking for the wrong card, then exploitation had failed. So the question is, what is the trade-off? If we explore too much, we are wasting time instead of working on the profitable ones because we are exploring for a longer period of time. But if we explore too little, I'm talking of exploitation, we risk missing out on new strategies, new trends, because we don't know whether the same card will be preferred over a period of time. So question is, what is the trade-off? How much should we explore and how much we should exploit? Now this is a classical example in the business world which we call as multi-armed bandit. You might have studied or read about this. So these are the 4 slot machines I have, and one slot machine is best. It gives you the maximum return. Once I put and I put the lever down, I get always good results out of that. But I don't know which is that machine. So what I can do is I can try all and then spend time at the best one which I've identified. So when I talk about strategy choices, the classical example I took of multi-armed bandit is find the best strategy and then exploit continuously. But that was working well, but in today's dynamic world, that is not the case because there are many possible courses of action and big data is there and people can exploit and discover what is changing, what is not, and in this changing world, the choice which a customer has made yesterday may not be there today. So changing very fast. and it is very competitive world, and it has gone global, and there is a lot of uncertainty. Like in the COVID times, you don't know what are the preferences, so things change very fast. So this classical strategy may not work. So what are the other strategies? So people keep on researching on that, and I am quoting this from HBR. This is from researchers Reeves, Zhang, and Vinzera. They have given this concept of self-tuning enterprise. So first is the adaptive strategy. So what is that? So you do experimentation at a constant rate, and but also exploit. But your experimentation is going on at a constant rate, and you learn through AI as to what to exploit, and you keep on exploiting. For example, I spend 10% of my budget or time, that is my resources, on experimentation, and I exploit 90% of the time the best choice which comes out of that experimentation. This is again good, but it is again fixed. But there is a new concept which I said has been given by Reeves, Jeng, and Vanzera, is self-tuning. So many companies had already been using it, and many have started using that. What is that? That is where the AI comes into play. Change the rate of experimentation depending on the situation. So rather than fixing 10%, as I took an example in adaptive strategy, we change the rate of experimentation, and which will be dependent on the situation. So we use data and discovery to inform experimentation, when to experiment more, when to experiment less. So that is controlled by my artificial intelligence. For example, in times of disruption, when a lot of innovativeness is happening, I increase the experimentation. And when in the stable times, I focus more on exploitation. So they have done a lot of research. I have quoted the reference in the further reading. So if you want to know more, you can go into the depth of this. So they have done a lot of research. So they have three phases in this second diagram: when the time is stable, when the time is dynamic, and third is stabilization of the new norms. Like, for example, in COVID, this is a new norm we are living in. So they have compared with the data the classical strategy, the adaptive strategy, and self-tuning strategy. If you look at self-tuning strategy, that is a linear growth which is going up. So whereas in case of the adaptive strategy, which is good, but it is may not be giving you the results in terms of the self-tuning. Classical strategies goes up, down, and that is what you can have a look at. So one of the companies which had been doing, let us take a case study on Alibaba, which has been using the self-tuning strategy. So started in 1999 in a small apartment. You might be knowing the story of Alibaba. 2003 they started with the Taiboa marketplace, then a mall. Later they called that as a T mall. 2016 they diversified into the internet domain, and 17 they have now into cloud and digital media. Now, if I look at their history, and you know about Alibaba in 2006, right? So they were having Alibaba.com, Taibu Marketplace, which they called later in 2008 Tmall, and Alipay, which is one of the leading money transaction portal which they have. Ali Wang Wang, all were doing well in 2006. How many of them are there now? Not all. So in 2006, they found two new trends with their experimentation of the self-tuning mode. One was B2C e-commerce. So they immediately launched, they changed in 2008 to Tmall. And then SaaS, which is software as a service. So they immediately launched the AliSoft. So these were the things which they did. What happened to AliSoft? Gone now. And was at its peak at some point of time. So this is what Alibaba is working on exploration and exploitation using self-tuning strategy. So that is all, my friends, which I have to say in today's lesson. So if I have to summarize, I gave you the introduction of prescriptive analytics, and then we talked about the optimization and simulation models which we use in prescriptive analytics, and then we moved on to the next value under the ESL model, which is AI in business. We saw how the machine learning and AI is being used in the business houses now. And then we talked about voice and NLP, and we looked at the various ways in which you can use that. And especially we took the example of the bank customer service, which they are going to employ soon. And then we talked about AI and strategy, how you can pick the strategy, and we talked about the two E's in that. So here is a small quiz for you. Please answer the three questions. Number one is, what are the three elements of optimization model? Number two is, for using AI in strategy, name the two E's for trade-off. And number three is, which is the best strategy choice which Alibaba has used for AI? Answer to question number one is, three elements are decision variables, objective function, and constraints. Answer to question number two is, the two E's are exploration and exploitation. And answer to question number three is self-tuning strategy which you can use, which Alibaba is using. If you have any questions, feel free to write to me and I'll get back to you. And this is the link I was talking about the self-tuning enterprise, which you can go into the depth by going to this URL. Thank you very much for being such a good audience, and you have a good day, and I'll come back with the next lesson very soon. Bye for now. Shabbat Khair.